All right, well, let's go over the questions that related to the lab. I did a little video off the back of my porch with the thing called the bimetallic strip, right, and the ring and ball thing. So on this one, the questions were, the first one says, given that the bimetallic strip is made up of two different metals, a layer of brass and a layer of iron, why did the strip bend when it was heated? So when it was heated on my gas grill, what actually happens is those molecules start to move a little bit. Right? Remember that they're really, really close together, just vibrating. But when they heat up, they pull apart just a little bit. Not very much. I don't want you to think they pull apart like this. They just pull apart a little bit. All right? And what ends up happening is the brass and the iron pull apart at different amounts. So one of them pulls apart farther than the other. And when they do that, then the one that pulls apart farther ends up expanding more than the one that pulls apart less. So we end up with the one that pulls apart farther makes a longer piece of metal, and it goes on the outside of the curve. And the one that expands less goes on the inside curve. The way which I always like to describe this one is if we went go-kart racing. Right? So all of us, everybody in the class, we went go-kart racing, and as we all know, I would be in the lead. Right? You're going, yeah, right, okay. But let's assume I'm in the lead, and you want to pass me. If you want to pass me and I'm going around a corner, where do you want to be if you want to pass me? Well, if you know racing, you want to be on the inside curve. Right? You don't want to try and pass me on the outside because the outside is a really, really long distance. The inside is a little short curve. So if you can take the inside, you can take a shorter amount of distance and you can beat me on the curve. So the one that expands the least is the inside. The one that expands the most is the outside of that bend. Right? Now, number two, what happened to the strip when it was placed in cool water and why? When you place it in cool water, then all of a sudden it went and it straightened back out. Why did it do that? Because all the molecules went and they got closer together again. Right? When they heated, they pulled apart. When they got cool, they went back together. Now remember, I'm only moving just a little bit, not very much, because they don't move very much, but they do move a little bit. All right. Number three, describe how the strip is used in a thermostat that controls the heat in your house. Hold on, I'm going to pause for 1 second. I'll be right back because I'm going to go grab my thermostat. All right, I'm back. So I went in my back room and picked up my old thermostat from my house. It was really, really old, and its plastic's getting all discolored from sitting in my back room now for years. But what this thing actually does is it controls the temperature in your house. Right? And there's a little lever. Actually, I should hold it this way because that would be the right way. There's a little lever over here that you turn up and down to make your house hotter or colder, right? I don't know if you can hear it, but listen to it. It makes a little sound. So it's making a little clicking sound when I move it up and down. Well, if we take the lid off and watch inside, there's a little spot over here that's actually touching things. And what it's doing is it's actually turning my furnace on and off. And as I turn this thing up, watch it move. There it goes, it moved down. Now as I take it down, there it goes back up. So I take it back up and it moves down and down and up. All right. Now if you notice there's a little piece of metal that attaches to it right here, and that goes behind this plate and it's all spiraled around on there. What that thing is, that's a piece of that bimetallic metal. And when I turn on my furnace, right, when my furnace is on, my house temperature goes up. And as my house temperature goes up, remember that bimetallic strip will do this, and it bends down, right? And this thing will bend down, and all of a sudden it goes click, and it shuts off my furnace. When it turns off my furnace, then what happens to the temperature of my house? Well, the temperature of my house goes down. It actually starts to cool in the wintertime. And as that thing cools, then that piece of strip does this, and it bends up, right? And if you watch, all of a sudden it goes click, and it bends up, and it touches the top, turns my furnace back on. Furnace is on, the house temperature starts to get hotter. And as it gets hotter, this thing then bends down, click, and it turns my furnace off. And that's all it does. It just keeps switching back and forth. Right? So, and what we've done is this thing over here is if I want it really, really hot, now it's going to take a lot of temperature before this thing finally goes up and clicks and changes my temperature. Right? Some of you may also have a central air conditioning. This one wasn't designed to run air conditioning, but usually air conditioning units have a little switch at the top that says heat, off, cool. When it switches over to cool, what it does actually is it changes the switches so that they're controlling the air conditioner. And then what happens is that, I'll use my pen as the little switching mechanism, is that when it's touching the thing at the bottom, it makes the air conditioner go on. when the air conditioner is on, what happens to the temperature of the room? It gets colder, right? So as it gets colder, then that little bimetallic strip straightens out. So as it straightens out, it goes click and it shuts off your air conditioner. In the summertime, when the air conditioner is off, then your house gets hot. As it gets hot, then this thing starts to bend down and it goes click and it turns the air conditioner on. Air conditioner's on, the house gets cooler, this thing straightens back out, click, it shuts off your air conditioner. And it keeps doing that. And then again, all we do is we're really just kind of like moving this switch to a point if we change that temperature. So that's how we utilize that bimetallic strip inside of our house. We all probably have one. Now, if you have a digital one where it's got a little digital readout, then that's different. Then it's utilizing electrical impulses in order to do it. But if it's mechanical like this one, then it's actually using a bimetallic strip. All right, number 4, what happened to the ring and ball when the ball was heated? So if you watched on there, I had the little ball thing, or the little ring thing in the ball. When I heated the ball, then it wouldn't go through the ring, all right? Because it had actually expanded a little bit and got too big to go through the ring. Number 5, what were the 2 ways that the video was able to get the ring and ball back to original? Well, one way is let the ball cool down, right? Or stick it in water. If you stick it in water, it cools it down, it shrinks back down, then it'll fit through the hole. Or what you can do is you can take the ring part and you can put that in the heat it up, and it'll get a little bit bigger. And then the hot ball will go through it. All right, so those are the 2 different ways. You can cool down the ball or you can heat up the ring. So number 6, how does this apply to the spacers and sidewalks? If you've ever noticed, and I want you to look now when you're out walking around, is if you look on cement sidewalks, they're like little squares. And every so often in those little cut lines, you'll see this little black stuff that goes in between. And what that black stuff is it's a spacer that can get squeezed and expand. Because when the sun shines down on that cement, it makes the cement hot. And when the cement gets hot, then it expands a little bit. And when it expands, it's going to push against those little spacers and make them go smaller. Right? And then at night, when it cools down, then they're going to shrink and they pull apart a little bit. And during the daytime, they push together. And at night, they go apart. So it allows them to go back and forth. If we didn't have those, we'd have cement right against each other. And in the daytime, when they'd heat up, they'd go and they'd break. And then when it pull apart, then you end up with this big old hole inside of your cement. We have the same thing on the roads. If you ever notice when you're driving down the roads, you hear with your car, it's going da-dit, 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 as you're going down the road. Those little da-dit sounds, those are actually spacers in the road. And make it so that the cement can go like this, back and forth, depending on hot and cold. They're expansion joints. All right, number 7, if you wanted to remove a bolt that's rusted in a part in your car, which I do periodically because I work on my own cars at home and with my kids. But how can you use this lab to help you? Should you heat the bolt or the part the car screws into? So you have this screw that goes into a part on your car. Which part should I heat? And if I heat the bolt that's going in, it's going to get bigger. It's going to be impossible to get out. So what I actually have to do is I got to heat this part here. And what that does is it opens it up, makes it bigger, and then it's a whole lot easier to back that screw back out. It's just a little piece of using science in order to make your life easier. That concludes that lab activity. So, talk to you later. See ya.